Welcome to another Math Ninja Pro video. In this video, we will learn about the three averages of statistical data: mean, median, and mode. But first, let us meet Annie, her friends, and her little brother. Annie is 164 cm tall. The heights of her friends and her little brother are as shown. Annie wants to compare her height with that of her friends. It is easy to compare two data points. We can easily see that Annie is as tall as Alex, and Annie is 5 cm taller than Sandra. But how tall is Annie compared with her 5 friends, whose heights are 168, 159, 164, 151, and 176 cm? It is not as easy to compare one data point with a set of data. In order to compare one data point with a data set, we need to find a number that best represents the data set. In statistics, we call this number a measure of central tendency, or a statistical average. It is a single value that approximates the center of a data set. There are three common measures of central tendency or statistical averages: mean, median, and mode. The mean of a data set is the sum of all the data values divided by the total number of data points. To find the mean height of Annie's 5 friends, we simply sum up all their heights and divide by 5, since there are 5 data points. This gives a mean height of 163.6 cm. Did you realize that finding the mean of a dataset has the same algorithm as finding the average that you have learned in primary school? Now that we have found the mean, which is the single value to approximate the heights of Annie's 5 friends, we can conclude that since Annie is 164 cm, she is just slightly taller than her group of friends. What if we want to find the mean height of Annie together with her 5 friends? Then, the mean height of the entire group can be found by summing all the 6 heights and dividing by 6. This gives a new mean of 163 2/3 cm. We can see that because Annie's height is 164 cm, which is slightly more than the previous mean of 163.6 cm, adding her height to the data set to recalculate the mean only increases the new mean by a little bit. The median of a data set is the middle value when all the data points are arranged in either ascending or descending order. Let's arrange the heights of Annie's 5 friends in ascending order. We can see that the middle value is 164. Hence, the median height of Annie's 5 friends is 164 cm. Like mean, the median height is a single value that approximates the heights of Annie's 5 friends. And since Annie is 164 cm, she is as tall as her group of friends. What if we want to find the median height of Annie together with her 5 friends? Then, we need to arrange the heights of Annie and her 5 friends in ascending order. We can see that because there is now an even number of data points, there are 2 middle values, which happen to both be 164. In this case, the median height of the entire group is given by the average of the 2 middle values, 164 plus 164 divided by 2. So, the median is just 164 cm. In general, when there is an even number of data points, the median is the average of the 2 middle values. The mode of a dataset is the value that occurs most often. If we look at the heights of Annie's 5 friends, we see that there is no repeated value. Hence, there is no mode. Let's see what happens when we add Annie's age into the dataset. Now we see that there are two counts of 164, making 164 the value that occurs most often. Hence, the mode, also known as the modal height, is 164 cm. Each of these measures is calculated using a different method and gives a single value that represents the dataset. These measures enable us to analyze and compare a single data point against a dataset. We can also calculate the mean, median, and mode of two or more datasets to help us analyze and compare datasets. Now let's see what happens to the mean, median, and mode of the dataset when we add little brother's height to the dataset. We have previously calculated the mean height for Annie and her 5 friends to be 163 2/3 cm. To calculate the new mean with little brother's height added to the dataset, we simply need to add 64 to all the other heights and then divide the sum by 7, since there are now 7 data points. This gives a new mean of 149 3/7 cm. It is not surprising that the new mean is so much smaller than the previous mean, because little brother's height is an outlier, and an outlying data point will affect the mean, since every data point is used to compute the mean. We have also previously found the median height for Annie and her 5 friends to be 164 cm. To find the new median height with little brother's height added to the dataset, we simply need to add 64 to all the other heights and arrange the heights in ascending order. Since there is now an odd number of data points, there is only one middle value, 164. Hence, the new median is 164 cm. It is not surprising that the new median is not affected by the outlier, since the outlier has little impact on the middle values of a dataset. Previously, we also found the modal height for Annie and her 5 friends to be 164 cm. To find the new modal height with little brother's height added to the dataset, we simply add 64 to all the other heights and look for the most frequently occurring value in the dataset. It is still 164. Hence, the new mode is 164 cm. Again, it is not surprising that the new mode is not affected by the outlier, since the outlier usually has no impact on the most frequently occurring values in a dataset. Outliers affect certain measures of central tendency more than others. Different scenarios or contexts may require the use of different measures of central tendency to interpret the data in a meaningful way. Choosing the best measure of central tendency depends on the type of data, the distribution of data, and the context. When we wanted to compare Annie's height with that of her 5 friends, we can use mean, median, or mode to do so. But if we add little brother's height to the dataset, we may only want to use median or mode, since little brother's height is an outlier, which significantly impacts the value of the mean. Let's consider these scenarios to see which is the most appropriate statistical average to use. In the case of academic grades, such as A1, A2, B3, and so on, it may be more appropriate to use mode for comparison. For example, if most students scored B3, then the mode would be B3. We can also use mean for comparison. For example, if the mean score is 1.5, it means that most students in the dataset scored either an A1 or an A2. For favorite color and t-shirt size, we should be using mode for comparison, since the mode will give us the most popular color and the most popular t-shirt size. For household income and house prices, we can use median for comparison, since the median will not be affected by outlying values. For birth rates, sales per day, and calorie intake, we can use mean for comparison to include all the data values into the calculation.
Remember to like, subscribe, and keep coming back for more Ninja level math videos.